In this video, I'm going to go over how we can decompose a composite function into two separate component functions. So what we're going to do here is we have this function f of x. So square root 5 minus x squared. So what you want to do is you want to identify kind of an inside function and an outside function. And there's often more than one way to do this, but this is something that's useful if we start taking a calculus class and we're doing integrals. We want to be able to identify the inside part of a function and an outside part of a function. So I'm just going to label these as h of x and g of x, the things that I'm going to be finding. And one thing to notice, we have square root of 5 minus x squared. So I can say that the inside function here is 5 minus x squared, and that is getting input into the squaring function, or the square root function. Okay, so I can verify that this is true by saying, well, if I input the h function into the g function, so if I say g of h of x, I'm going to take that h function, which is right here, and then I'm going to input it right into here, and that'll give me f of x, which is what we started with. So that's great. Another way of doing this one is, well, let's say h of x is equal to x squared. So if h of x is equal to x squared, g of x would be the square root of 5 minus x. So if I input the h function into the g function, what it's saying is, well, take the h function and input that into the g function. So I'd get 5 minus x squared, and that is f of x. So we got it. Okay, so as we can see, two obvious ways. There's probably other ways, but those are maybe the two most obvious ones. And then let's do these last two examples. So let's write f of x, which is equal to 4 over 3 minus square root 4 plus x squared as a composition of two functions. I don't know why I did h of x and g of x in that way. They're kind of out of alphabetical order, but I guess it doesn't really matter. So let's say h of x, let's let that be the input function. So how about square root 4 plus x squared? And then the function I'm inputting that into, let's say 4 over 3 minus x. So if I'm inputting the h function into the g function, I'd be putting it right there, and that would give me what I'm starting with. Let's see if we can come up with another one here. H of x, g of x. We can do it much like we did this one up here, where we could say h of x is just x squared. But another way we could do this is by saying, well, let's let h of x be 3 minus square root 4 plus x squared. And then let's let g of x be 4 over x. So if h is getting input, I would take this guy and put it right down in the denominator, and that would give me what I started with. All right, and one last example here. We have 1 over the square root of 2x squared plus 1. I'm going to say h of x is equal to 2x squared plus 1. And if g of x is 1 over the square root of x, if I'm going to input h of x into this function, that will give me what I started with. So you can try that one on your own and see if you can come up with anything else that will work.